horizontal motion because it's a pendulum. And so therefore it's going to be moving like that. And so it's very important for us to understand that there's two components to this. And when we change the orientation, we can better visualize these components, right? So we have a X component, and then we also have a Y component. Okay. And let's say I took this here and I just changed its orientation counterclockwise. So where the gravity is now pointing here, right? So let's say that this is, and keep it consistent, right? Okay. And we have FG. FG, we see, has an angle. And so therefore is going to have components. So in trig, right, we know that SOH, CA, TOA, right? Sine, opposite, hypotenuse, cosine, adjacent, hypotenuse, tangent, adjacent, opposite, adjacent, excuse me. And we're paying attention to the tangent, cosine, and the sine, but in our case, it's really just going to be these two. And so we look at and we see what we have. We have opposite angle, right? And we also have an adjacent angle, all right? And pretty much you just pick the one that is right next to it. So if the cosine is adjacent, that's going to be the cosine of FG. And if opposite is sine, that's going to be the sine of FG. So we just replace the A and the O. And we're going to just pretty much take FG. So we said FGY, it's a better color. FGY is going to be FG sine of theta. And then, so that's what this component equals. So that means that vertically, that is what, so I just realized I did this wrong. So this is actually the adjacent. So then it's going to just be, instead of sine, what is it going to be? Cosine, right? So it's just going to be FG cosine, right? And then this one, because it's opposite, this one is going to be FG sine. Okay, beautiful. All right, and so this is where this comes from. So you see that this one is pointing in the horizontal motion, and that is also proportional to the FGX. And what is FGX? FGX is FG sine of theta. And we know that FG is just mass times gravity. So that's what this comes from. Okay. And so the radial component along the tension supplies a centripetal acceleration. So we know that this whole thing is moving. That keeps the bob moving along a circular path. The tangential component is the restoring acting on the bob, tending to return to an equilibrium position. The force is a restitution force, okay? And that restitution force, we call that pretty much F equals negative mg sine of theta. All right, and this is the force that is allowing pretty much the pendulum to bob. All right, y'all, see you next video.